Here are 20 unknown facts about 3D printing using space construction. 1. The first 3D printer to be sent to space was the FabLab printer, which was launched to the International Space Station, ISS, in 2014. 2. One of the key advantages of 3D printing in space is the ability to create objects with complex geometries that would be difficult or impossible to produce using traditional manufacturing methods. 3. In 2018, NASA tested a 3D printed rocket engine combustion chamber, demonstrating the potential for using 3D printing to manufacture critical components for space propulsion systems. 4. The European Space Agency, ESA, has experimented with using lunar regolith simulant to 3D print structural elements for potential lunar bases, showcasing the potential for using local resources in space construction. 5. NASA is exploring the use of 3D printing to create biodegradable tools and equipment from plant-based materials, offering the possibility of sustainable manufacturing in space. 6. Researchers are developing techniques to 3D print using a mixture of metals and ceramics, opening up the potential for creating advanced composite materials with unique properties for space applications. 7. 3D printing in space allows for on-demand production, reducing the need for extensive inventory and storage of spare parts. Astronauts can simply print the required items when needed. 8. In 2019, the first-ever 3D printed space antenna was deployed on the ISS. This antenna was manufactured using a 3D printer called Refabricator and demonstrated the potential for in-space manufacturing of large-scale structures. 9. The ability to 3D print in space reduces the dependency on resupply missions from Earth, enabling longer-duration space missions and increasing self-sustainability for astronauts. 10. NASA has been exploring the concept of using regolith-based 3D printing to create protective shields against radiation for future crewed missions to the Moon and Mars. 11. Researchers are investigating the use of 3D bioprinting in space to create living tissues and organs for potential medical applications during long-duration space missions. 12. In 2020, the first 3D printed human heart tissue was produced on the ISS, advancing the field of bioprinting and potentially paving the way for organ transplantation in space. 13. In addition to structural components, 3D printing can be used to create functional electronics, such as antennas and sensors, enabling the integration of electronics directly into 3D printed structures. 14. 3D printing can potentially reduce the amount of waste generated during space missions, as materials can be recycled and reused for future prints, contributing to a more sustainable approach to space exploration. 15. The ability to rapidly prototype and iterate designs using 3D printing allows for faster development and testing of new technologies and concepts in space. 16. The reduced weight and volume of 3D printing equipment compared to traditional manufacturing equipment make it more feasible for space missions where every ounce and cubic inch matter. 17. 3D printing technology has the potential to enable the repair and maintenance of critical systems and infrastructure in space, reducing the need for costly and risky spacewalks. 18. In the future, 3D printing could enable the creation of large-scale structures in space, such as space habitats or even space-based manufacturing facilities. 19. The flexibility of 3D printing allows for the customization and optimization of objects based on specific mission requirements, leading to improved performance and efficiency in space systems. 20. The continuous advancements in 3D printing technology, materials, and techniques hold the potential to revolutionize space construction, making space exploration more sustainable, cost-effective, and enabling the realization of ambitious future missions.